Hello class, welcome to today's video. I was going to do this in the Meet with you, but since the Meets aren't working, I thought I'd go ahead and record a quick Edpuzzle. So first, to go over the warm-up. If you didn't do the warm-up yet, go ahead and do that. It's a Google form. And just to go through it real quick, we have the first one is 2-1 a solution. So 2-1 is right here. That's in the shaded region. So yes, that's a solution. So if you're in the shaded region, it's a solution. If you're outside of the shaded region, it's not a solution. For number 2, you had the point 4-2. 4-2 is on the dotted line. So remember, if your point is on the dashed line, it doesn't count. That's not a solution. If your point's on a solid line, then it would count. But 4-2 is on a dashed line, so you should have put no for that. All right, and then here for this one, I have a new inequality. Here's the shaded region, and it's a solid line. So taking a look at -1, 2, -1, 2 is here. That should be checked. That is a solution because it's in the shaded region. 0, 4 is the next one. 0, 4 is also an answer. It's also a solution. -1, 3 is here. That is also an answer. And 1, -2 is here. That would not count as a solution. 1, -2 would be not a solution because it's not in the shaded region. Okay, and just a quick note, if you were on the solid line, so if you were here, or if you were here, or here, those would count as solutions. So solid line counts as answers, the dashed line does not. All right, what we're going to do next is we're going to go through a word problem. So if you have the ability to print this handout, I would suggest that you print it. It'll make your life a little easier. Otherwise, you can copy it down as we go. So go ahead, if you need to, you can pause the video to copy the word problem. So we have up to $125 to spend on clothes, and pants are $20 each and shirts are $15 each. We're told to use X as the number of pants and Y as the number of shirts. We want to write an inequality to determine how much we can buy. Okay, so algebraic model is just the equation, or in this case, an inequality using X's and Y's and any numbers and operations. So we have $20 per pair of pants, and we're told that X is going to represent the pants. So it's going to be $20 per pair of pants. If we buy one pair of pants, can you picture plugging in one? It costs $20. If we buy 2 pairs, it would cost $40. If we buy 3 pairs, it would cost $60, and so on. We're also going to buy some shirts. It's $15 per shirt. So Y is the number of shirts. So we're going to add, this is how much we're going to spend on pants, depending on how many pairs of pants we buy. And this is how much we're going to spend on shirts, depending on how many shirts we buy. And we have up to $125 to spend. So I'm going to put 125 here, and we have to pick the inequality. So in that position, should I be putting greater than, less than, greater than or equal to, or less than or equal to? What's going to go here? You want to put less than or equal to, because that's the most that you can spend. Okay? You don't want to put a greater than, because then you'd be saying this is how much I'm spending is more than 125. You can't do that. You can spend 125 or less. So it's okay to spend 125 or less. Okay, so that's also why we put the or equal to, because it's okay to spend that total amount. All right, now, if we were going to graph this, we would have to solve for Y. So let's go ahead and do that work. To solve for Y, I'm going to move the 20x to the other side by subtracting it. Let me switch over to pen. That shows up a little better for you guys. So I have 15y less than or equal to. I'm going to put the x term first because we're trying to go for slope intercept here. And then we're going to divide both sides by 15. As a shortcut, we can go ahead and divide each term by 15. We don't need to reverse the inequality here because we divided by a positive. It's only if you divide or multiply both sides by a negative that you need to reverse the inequality. -20 over 15 reduces by 5. That's going to give us -4/3 x. And then I have plus 125 over 15. I know 5 goes into both of those. So 5 goes in here 3 times, and 5 goes into 125. Let's see, it goes into 12 twice, and then 25. So 25 over 3 is that next fraction here. So this is now reduced. And remember, it's okay to show work. You don't have to do the division in your head. It's always okay to show some work for that. So this is what we would want to graph. Take a look at that. What's the slope? This is the slope. And what does this represent? That would represent the y-intercept because we're in slope-intercept form, all right, where m is the slope and b is the y-intercept. Now, this is an inequality. It's not an equation. So when we go to graph, we're going to have some shading to do. So since these are awkward numbers, what I did is I went ahead and graphed it for you. So this is the graph if you graph this inequality. And you can see that it's a solid line because it says less than or equal to. And we're shading below because it says less than or equal to. So from our warm-up today, we would think, okay, every single point in the shaded region is a solution. Now that's normally what we would do. But since this is a word problem, we have to think real life. X represents the number of pairs of pants. Y represents the number of shirts. So if you think about this graph, only quadrant 1 makes sense. Only quadrant 1, oops, you can't see that. Okay. Only quadrant 1 makes sense. The fancy word for that is feasible. Reasonable is another word for that. So only quadrant 1 makes sense here, or is feasible, or reasonable for us, okay? Because X is the number of pairs of pants. You can't have -2 pairs of pants. You can't have -7 pairs of pants. That makes no sense, okay? And Y is the number of shirts you're buying. You can buy 1 shirt or 2 shirts or 3 shirts, but you can't buy -6 shirts. That doesn't make any sense in context of the problem. So even though in the warm-up today, any point in the shaded part counted as an answer, that's not going to be reasonable for the problem that we're doing today. So what we want to do here is interpret. I've selected some points for us to look at. We want to interpret the meaning of those points. So let's go ahead and do that now. So first is 8,3. 8,3 is here. Okay, that point is outside of the shaded region. So the 8 represents the number of pairs of pants and the 3 represents the number of shirts. But since it's outside of the shaded region, it's not a solution. Okay, so this represents 8 pairs of pants and 3 shirts. Since the point is not in the shaded region, it means we can't afford it. So because it's not in the shaded region, it's not a solution. We can't afford it. And let me grab another piece of paper and we can discuss why we can't afford that. Okay. So if we look at this and think about it, if we think, so you don't have to write down this part, about the equation that we wrote. We have 20 per pair of pants that it costs and 15 per shirt that it costs. If we were to buy 8 pairs of pants, I think I said that wrong before, 20 per pair of pants and 15 per shirt. If we were to buy 8 pairs of pants, that would be $160 on pants. And if we were to buy 3 shirts, that would be $45 on shirts. The total there is $205. That's more than we have to spend. The most that we had to spend was $125. That's what it said in the word problem. We can't spend more than $125. So that's what this point means. If we were to look at this point, this is 6,5. This would represent 6 pairs of pants and 5 shirts. We can't afford that either. It would add up to too much money. All right. And this point here is 3,8. Okay. 3,8 would be 3 pairs of pants and 8 shirts. We can't afford that either because it's not in the shaded part. So anything out here that's not in the shaded part is just going to be too expensive for us. All right. Let's go ahead and interpret the meaning of this point 2,4 in context of the problem. Here's the point 2,4. 2,4 is inside the shaded region. I'm going to cover this up just to get some more space here. Okay. So 2,4 is the next point we're looking at. So here's 2,4. Since that's in the shaded region, we can afford it. All right. This represents 2 pairs of pants and 4 shirts. Since 2,4 is in the shaded region, it's a solution. we can afford, I'll say it, just to make it a little shorter. We can afford it. So we can afford to buy 2 pairs of pants and 4 shirts. Now, just as a little extra, so you guys want to write that down, you can pause the video and write that down. But just as a little extra to think about this and what we just found, we say we can afford 2 pairs of pants and 4 shirts. If we look back at the inequality we wrote, we had $20 per pair of pants and $15 per shirt. So in this scenario, we'd be spending $40 on pants. And in this scenario, if we buy 4 shirts, we'd be spending $60 on shirts. That adds up to $100. Can we afford that? Yeah, because we have up to $125 to spend. So not only can we afford that, but we'd actually go home with $25. So that's what this point represents in context of the problem. If we were to look at this point here is 4-1. This would represent 4 pairs of pants and 1 shirt. We could afford that because it's in the shaded region. This point here, let's look at this point here, 1-6. Okay, that's 1-6. That's in the shaded region. That represents 1 pair of pants and 6 shirts. We can afford that as well. Okay, and even points on the solid line would work for us as well. So if you were to figure out the number of pairs of pants and shirts there, you could also work with those values. Okay, next is the point -3.5. And again, I'm just going to give myself a little more space here for that next part. So it was -3.5. Yeah, was the next one. All right, let's take a look at where that is. Here's -3.5. All right, now at first glance, you might say, oh, that's in the shaded region. We can afford that. Okay, but be careful because this is a word problem. This is a real life scenario we have to think. This represents -3 pairs of pants. We can stop right there. This makes no sense at all. Okay, this point is not in we call this the feasible region here. It's not in the part of the graph that's reasonable. It makes no sense at all. Okay, so -3 pairs of pants, that doesn't exist. So we should only be looking at points in quadrant 1. Or you don't have to write -3 pairs of pants doesn't exist. You could write -3 pairs of pants doesn't make sense. Negative X numbers don't make sense here. Negative Y's don't make sense here. You could write down anything like that. It doesn't have to be exactly these words. And let's just remind ourselves, we should only consider points in quadrant 1. And we usually use Roman numerals for quadrants. Just to remind you, quadrant 1, this would be quadrant 2, 3, and 4. So when it comes to this real life word problem, we only want to consider the points in quadrant 1 because we can't have negative pairs of pants or negative shirts. So for example, if we consider another point here, let's look at 4, -3. This would represent 4 pairs of pants and -3 shirts. That makes no sense at all. We shouldn't think about any points in quadrant 2. We shouldn't think about any points over here in quadrant 4. And we definitely shouldn't think of any points in quadrant 3. Because, for example, check this one out. Okay, so this is negative. Let's pick something a little different here. Let's go with this one. I keep picking numbers with -3, and it doesn't have to be a -3. So let's go to -4, -8. Okay, this definitely makes no sense. I know that this is in the shaded region, but in context of the real life word problem, this makes no sense. This would be -4 pairs of pants and -8 shirts. That doesn't make sense at all. So in this problem, we should only be focused on quadrant 1. Okay, thanks for watching. What you guys are going to do next is you're going to go ahead and try example 2 on your own. Once you're done with example 2, you're going to fill out the Google form to go along with it. Okay, and one thing just to remember, just to repeat for you, is when I wrote down my interpretations of these points, this is the wording that I used. It's okay in the homework if you use different wording. So for this 8.3, where we said over here that we can't afford that, we can't afford to buy 8 pairs of pants and 3 shirts because it's not in the shaded region, you can word that differently. You could say 8.3 is not in the shaded region, so we cannot afford 8 pairs of pants and 3 shirts. Okay, did you hear that? That's different than what I wrote. You can put it in your own words. I'll say it again. The point A3 is not in the shaded region. that means we can't afford 8 pairs of pants and 3 shirts. Okay? So just to give you some options, and I look forward to seeing what you guys put in the Google form for your interpretations in the next word problem.